Hello everyone. Good evening, and welcome you all to this session on from proactive to reactive to predictive. How are we actually unifying visual inspection and asset intelligence for the quality excellence? So myself, Surya, I'm the worldwide product manager for Maximo Application Suite within IBM. So I've been working from the past 2 years with IBM, and I closely work with the sellers and the business partners, especially on the field sales enablement, and I handle the go-to-market strategies across asset-intensive industries with a focus on the manufacturing. So if you look at a quick agenda at a glance, what am I going to cover in this session? It's more on the industry challenges that asset-intensive industries are facing and why IBM is identified as a client zero. So I'm going to walk you through some case studies that we have done with an IBM as a client zero and how are we actually unifying the visual inspection and the APM that you have gone through from the morning, and a quick overview of mass applications that we are utilizing for this use case, along with a pilot demo where I'll be showing you some videos and snippets on how these closed loop insights work in action and how are we trying to scale this transformation to form an enterprise adoption blueprint, along with some cross-industry use cases that might be applicable within your industries. So let us quickly start with what are the challenges that most of the asset-intensive industries are facing. So most of them are facing growing pressures, especially on the need to improve the efficiency and other key KPIs that you manage on a day-to-day basis. So adapting to new demands is another key challenge because of the supply chain volatility that the world is facing with all the tariffs and all. And then yet, there are multiple persistent barriers, especially to bring the assets, data, and the people to be in a connected mode, which is actually keeping the organizations locked with reactive modes of operation, and you are unable to take that baby steps even towards the predictive or proactive. That's where we have identified some of the bottlenecks. So if you look at some of the bottlenecks that are listed here, the first one comes on the eliminating downtime and the process efficiencies, which is really important to ensure that business continuity. So the second one that we hear is on the higher defect rates and inconsistent quality output that is more applicable to the manufacturing and the discrete and process manufacturing side. And we also have another key bottleneck, which is on the bridging IT/OT gaps. That is one of the key challenge most of the industries are facing with the equipment, aged assets that are in the line. How can we connect them, which serves as a foundation to build the digital transformation pyramid. And the fourth one, we have workforce shortages and skill gaps, which is one of the major issue. And we also have health, safety, and risk management, along with supply chain volatility and material shortages. And finally, the biggest bottleneck is on the sustainability and regulatory compliance pressures, where industries are trying to adopt. And if you see some of the numbers, the industry reports that are backing these bottlenecks, the cost of unplanned downtimes is doubled. So as Cantor highlighted in the morning session, it's almost 2x from the last 5 years. We also have more than 50% of the organizations who are still running on preventive maintenance and the traditional ways of running the assets until failure, practicing time-based preventive maintenance. And the third one, 35% of the organizations have accepted that there are pressing concerns on the workforce productivity, especially on the engagement and retention. And finally, 88% of the organizations have agreed that decarbonization is going to be the top driver, especially when you want to meet your sustainability and compliance and adherence regulations. So with that, let me quickly brief you on what we actually hear from the clients in our conversations on a day-to-day basis. So we actually interact with a lot of personas within an organization, let it be a reliability engineer, your maintenance manager, right from the C-suite till the shop floor. So whenever we talk to like a maintenance technician or a reliability engineer, and the production managers as well, the first bucket that we hear is on they want to decrease the downtime and improve maintenance, which is their biggest pain point to make sure the business is continuity. And why? Because is that you have average cost of unplanned downtime is almost 25K per hour, which is really they cannot afford. And they also have 30% in excess maintenance cost going towards false positives because the frequent alarms and not accurate thresholds that they're going to set with the data that they have. And also 70% of the hours lost across reactive versus proactive maintenance practices, preventive practices, I would say. And if you look at the second bucket, we need to derive new value from the raw data. Who actually tells this? It's the reliability engineer and the asset performance engineer. They have the biggest pain point because they need to arrive at some decision making by looking at the data and making a meaningful sense of it. That is where we have 82% of the asset failures appear randomly with very little warning. And 99% of the data collected from the connected assets goes unused because there is no proper insights that is coming out of the tool. Rather than visualization, how are we trying to correlate the data that is coming with the capabilities that we have got in the system? And also on the third, which is the limited ability to link your asset data insights that you are collecting directly to the performance or the product quality outcomes that your machine is producing. And on the third bucket, whenever we talk to like field service operations manager, most of them say that we are losing the most experienced technicians, even the safety officer, where they quote that they have higher costs of safety and operational incidents across industries, which is almost 167 billion, and 30% of the total workforce being retired, and the average turnover in the field workforce is almost 32%, which is not really good. And finally, whenever we speak to quality engineers, we speak to service managers or warranty managers, they speak about these product defects and the warranty costs that they're actually bearing. So 1.2% of the annual revenue is being spent on the rework whenever you miss the defect and pass it on to the customer. So 2% of the revenue is spent on the warranty, which is really huge. And the cost of incidents is also increasing day by day. So whatever the quality incident or the defect that you're actually identifying, there is a direct or indirect cost that is being borne, which is almost 300 to 3,000 per incident. So with that overview on the challenges across asset-intensive industries, let me quickly walk you through and narrative why IBM as client zero and what are we trying to do by transforming inspection challenges into insights. So we have identified one of our IBM Semiconductor packaging line, which is in Canada. And this line is an SMT line, which we call it as a surface mount technology, where it is an automated assembly line where you manufacture printed circuit boards, which are PCBs. So when you analyze this line, we have some challenges that are being identified, which I'll speak about. And if you look at the chip placement inspection process, the line that we took, you have multiple assets under each stage. So after every stage of production, you have an inspection checkpoint. So these SPI, solder paste inspection, the automated optical inspection, which is AOI, which is at 2 stages, will actually demonstrate you how inspection is deeply embedded into the manufacturing process. So if you look at the top 4 challenges that we analyzed, that we identified when we analyzed this inspection process, the first one is on the complexity. So as the technologies grow, the PCBs become smaller and smaller, as you know. And it is really difficult to identify any kind of defects with the existing automated optical inspection that we have. That is where you need more sophisticated inspection logics, much advanced AI-level systems to detect and make your life easy. And the second key challenge is on the higher false positive rates. So in these kind of very accurate processes, I would say the SPC thresholds are very less. So the statistical process control, where we actually set the lower threshold limit and the upper threshold limit where the process outcome has to fall into. So when these SPC thresholds are accurate and very tighter, because you don't know how to set them due to lack of data visibility that you have, they are generating higher false rates. That is where you have to spend a lot of time in understanding it, which is all non-productive. So each alert actually drives manual intervention that delays your throughput as well. So on the third one, we have a lot of data overload. So every equipment has massive amounts of data. So this massive amounts of data, when collected, is actually straining your analytical capabilities because you don't have proper systems in place that gives you meaningful output and connect that closed loop framework. And on the fourth one, there is still higher dependency on the manual inspections because there is a manual checkpoint to validate whether the inspection outcome is accurate or not, which is actually impacting your both quality as well as cost. So with that, let me give you a quick overview on what are we trying to do as a client zero here. Where we are trying to drive real results and real innovation. And if you see what is our vision statement, as a client zero, we want to transform client experiences with proven industry-relevant use cases and real-time demos. So what are our core objectives here? We are trying to streamline asset operations and inspections. We want to optimize end-to-end asset workflows, where you want to connect the asset data, machine data, into a closed-loop framework to enable seamless execution. And on the third one, we want to automate for efficiency and productivity. That is where you want to reduce your manual interventions and then leverage AI-driven insights, especially to improve your KPIs like overall equipment efficiency, your productivity, your workforce efficiency, whatever is important. And finally, how you can leverage AI and Gen AI for predictive decisions, which will actually help you move towards data-driven decision making. And to summarize in a nutshell, we want to optimize asset lifecycle management, make use of the ALM suite of applications, elevate your product quality and serviceability, and accelerate operational excellence. So with operational excellence as the key, how is the success formula going to look like for the asset-intensive industry? So operational excellence is something which every industry will aim for. And what are the 3 critical pillars that will actually help you achieve that in these kind of scenarios? So the first one is on the performance and compliance. That is where your assets, your processes has to deliver and meet the industry standards. Not only meeting the standards, but they also have to comply with the stringent regulations that every region will have for its particular framework. And the second one is on the reliability, where you have to keep your assets running with minimal downtime. And the third one is on the scalability. That is where you have to adopt and grow with the changing demands, and how you can extend it across the enterprise to unlock the value across your entire value chain. So with the business challenges and the operational challenges that we have reviewed so far, the solution lies within the asset lifecycle management, where at every stage of your asset lifecycle, let it be your planning phase, your deploy, your operate, and optimize, as well as your dispose. At every phase, you're trying to optimize your asset lifecycle. That is where you're going to realize the value with multiple applications that are going to work together in this space. So if you look at some of the quick wins that we can achieve, these are the numbers from the IDC report, how you can increase your asset lifespan, you can increase your inspection accuracy rate, you can reduce your unplanned downtime events, and even quicker downtime resolution. So why Maximo? Why have we chosen Maximo specifically for this use case? Because it's a best-in-class ALM solution that we have, which is powered by AI, Gen AI, IoT, and predictive analytics. As Skandra highlighted in the morning, Maximo is the only ALM space that we have been ranked as a leader in both EAM quadrants as well as asset performance management quadrants. And with 40+ years of market presence, around 4,000+ customers, and watsonx Gen AI, which is powered by watsonx to enable AI capabilities with mobility and IoT support. And some of the reference logos are there. As you can see, Maximo is widespread across industries, all the asset-intensive industries, starting with manufacturing to E&U to even rail transportation and oil and gas as well. And let us quickly look into double tap what is Maximo Application Suite and different applications that are within the suite that work together. So as I already said, Maximo offers best-of-class capabilities to provide complete view of your assets, addressing the key needs of all the personas. So it can address the needs of your maintenance department, your quality, your inventory stores, and even your safety. So different applications manage, which is intelligent asset management. That is the core foundation. We have MREF that is coming into Maximo starting from 9.1. And we also have monitor, health, and predict, which is APM suite of applications, along with visual inspection that offers AI-powered insights. And these are multiple add-ons that you must be aware of already. And with that quick overview, let us see how all your asset lifecycle data comes under one suite. So we have Manage, that is the core foundation for Maximo Application Suite, where it understands the asset in place, and you can manage all the work executions starting from the work orders. And we have different applications that are on the right. And this will actually help you understand how all those applications are closely tied to Maximo. So we have brought these applications together so that you have that closed loop framework, starting with any kind of anomaly that you detect with the help of monitor, health, and predict, and how you can drive the service request and the work orders into the manage, where you have everything falls into one place. Let it be your reliability manager, your maintenance manager, and technician. They have visibility of all the data within the suite and how they can drive that database decision making. So let us quickly walk through on different applications that we are utilizing for this client zero use case. So Manage is all about optimizing your assets, work orders, and supply chain operations. So we have starting with work management, your work orders, your job plans, with asset management, along with the supply chain, your entire P2P process. You have planning and scheduling within Manage. You also have HSC, which is an add-on, followed by service management, your analytical capabilities through Cognos reports and BERT reports, and also the mobility piece, which Joao already covered. So this is a quick one-pager overview of mobile. How can you access your work anytime, anywhere? And mobile actually boosts your technician productivity with AI-driven prioritization along with connected and disconnected modes with the mobility and providing next-generation user experience. So let us take some time to understand what is APM, and I'll give you some deep dive insights on how are we trying to utilize these insights for our use case. So elevate your asset reliability and performance. Elevating your asset reliability and performance with APM is all about it helps you optimize your uptime, it will cut your maintenance delays, and lower the costs. So to explain how APM works in 4 steps, it all starts with collecting your right data to diagnose the failures in the PF curve. So the PF curve is basically the potential failure and the functional failure curve, where it starts with the design phase and followed by the installation phase. The P is the potential failure point, and F is the functional failure point. So Maximo APM will actually help you identify the defects, identify any kind of failures earlier within this curve. So that is where you need to have right sets of data configured in the right manner to make sure you detect any kind of variations that leads to failure earlier in the PF curve, moving you towards the condition-based maintenance or the predictive maintenance. And on the second step, monitoring and ingesting sensors data. That is where you have operational data and condition data that is coming into monitor that can actually help you configure the data insights. So you have multiple OT data, PLCs, and sensors on the shop floor. So if you look at within APM, we have EDC library where almost 1,600 plus pre-configured connectors are available for you to extract the data from your shop floor. So it can be PLCs, your SCADA systems, your sensors, any kind of parameters like vibration, temperature, and acoustics can be extracted within no time with the help of those connectors. And on the third step, how you actually do the data flow configuration. So this pyramid actually shows you the data structure hierarchy, where you have assets, devices, and sensors that are connected in the bottom, and how do you extract the data from the PLCs and the OPC UA servers, which will form the data layer stream, and the EDCs and the edge gateways will actually help you extract the data from the bottom 2 layers and push it into the monitor. That is where you set up the visualization piece and start driving the analysis. And on the 4th stage, where you have AI anomaly detection and actionable insights, this is where AI comes into picture. So once you onboard those devices, you can onboard thousands of assets, devices, and sensors, with each of the device having multiple metrics. So you can calculate your measurable metrics, calculated metrics that will impact your asset health, where you can configure the analytical models, like anomaly detection models, and then that will start driving your active alerts and basically helps you arrive to the root cause for any kind of issue that you find out. So asset health dashboards is one good tool that will actually utilize all these data based on your key parameters. The asset health monitoring will actually help you arrive at the root cause. So multiple capabilities within APM. So as you can see, Manage is at the center. APM is again built on Maximo Manage, which is integrated throughout for the closed loop framework. And asset health is another piece which I spoke about, where you can gain a 360-degree view of your asset condition, risk, and performance. So how you can track KPIs, how you can analyze trends, and also optimization opportunities. So the third important one is on the asset strategies. This is where you actually provide a foundation when you want to move from traditional maintenance strategies towards condition-based strategies. So asset strategies, which is RCM, is all about aligning your maintenance strategies with the objectives that you have through pre-built RCM failure modes, which are within this library. So we almost have around thousands of assets which are already pre-configured with the libraries, where you can generate FMEAs using AI-powered models. And finally, we have predictive anomaly detection, where you can leverage AI-driven models to detect any kind of deviations which are out of the box within monitor. You can predict failures before they occur, and you can automatically generate data-driven work orders. So how you can gain insights and take actions with APM? You can have multiple views where you can find critical assets and locations that require attention. You can have a matrix view. You can have different asset groups that can be viewed with an APM. And you can also drill down to investigate the problems with assets and locations, where you can monitor the meter readings. You can monitor the health timeline of the asset, along with multiple parameters that are being configured there. And finally, how you can take actions to drive continuous maintenance improvements. So with the click of a button, where you can generate service requests and work orders connected with Manage. So let us take a quick look on MVI, how you can accelerate quality excellence. And MVI is all about, it provides an AI platform where it will help your SMEs configure AI visual models right from out of the box. What do we have from the system without any expertise of data science or coding skills. So you can label, train, deploy. This is the framework that we use basically to deploy the models, especially on the high performance inference service, any kind of large scale implementations. And it can also integrate with your existing infrastructure, which is your fixed cameras. So MVI comes with 2 different modes of implementation. The first thing is on the MVI mobile, where you can do a mobile inspection with your iPhone. Or we also have Edge, which is used mostly in the industrial environments on the camera inspections. So with MVI, you can detect and correct defects when and where they happen. You can drive actionable results. You can quickly react to change because you identify the defects right at the point of installation. And you can also avoid failures. So different inspection models that comes out of the box with MVI is object detection. We have anomaly detection model. You have leak detection, and also the image segmentation. So with that overview of different mass applications, now let us reimagine the process that we have walked through in the IBM Semiconductor packaging line. So all the assets that we have within those chip placement inspection process, we have connected to Maximo Monitor. If we connect to Maximo Monitor and identify the contributors to the placement quality, especially like contamination, pressure, speed, and temperature through different sensors that are already there, and you replace the automated optical inspection with Maximo Visual Inspection. That is where MVI offers more flexibility and accuracy compared to the traditional AOI systems. And our objectives here, what are the deliverables that we are trying to drive here through this program, is all about scalable data management, enhanced anomaly detection, and how you can actually improve your reliability and uptime in these kind of scenarios. So now that we have arrived at the solution and we reimagined this process, before we actually go and implement directly on the production environment, we have decided to do a pilot use case. So that is where we have leveraged our IBM Innovation Labs. We have an innovation studio at Singapore where we have done a client zero pilot. So let us quickly walk through on what we have done there. So on the client zero case study, the use case that we have picked is the memory DIMM inspection with Cobot. So for all of you who don't know what is DIMM, DIMM is a dual inline memory module. It is an electronic component which actually assembles the PCBs. So what do we have here is a collaborative robot, which is a Cobot, a robotic arm that removes the DIMM modules. So we call that as a DIMM module. So it picks it up from there, and we have multiple cameras that are placed, which are the vision sensors, that will capture the photographs, and then it will actually sort out based on the inspection results that MVI is generating. So let us see how this is actually moving into a closed loop framework by introducing monitor into the picture. So how this pilot actually works, starting from inspection to execution. So on the left, you can see the entire setup is having the collaborative robot along with the vision sensor, which is a camera. So the edge data processor will trigger the start of inspection. So as I already said, the Cobot controls the precision movements of the memory DIMM, and as it passes through the cameras, the high-resolution images are being clicked throughout the inspection process. So these images are then uploaded into MVI Edge, where you have AI inference rules and the edge rules which are applied through the AI models that are being configured, and the MVI Edge will actually deliver the inspection results, whether it's a pass or a fail. And then these inspection results are being sent into edge data processor, where the data pre-processing happens. In this case, we are using Raspberry Pi. And these inspection results are then pushed into mass monitor through MQTT. So MQTT is a communication protocol that Monitor is compatible with, and we are converting these results into MQTT standard and then pushing into Maximo Monitor, which we use it for centralized data connection and analysis. And then, apart from these inspection results, we are also capturing the Cobot operational health data. So some of the Cobot operational health data are, the joint angles, torques, which will actually help you provide an overview of what are some of the parameters that is impacting the Cobot health. So this operational data is being collected, and then we are also pushing the data into Maximo Monitor, where we have analytics and anomaly detection that are pre-configured. And the beauty of this is the real value comes out when you start actually having the correlation capabilities. So you are collecting the inspection results, and you are also collecting the operational health data. So when you actually correlate these results, that is where you understand which is actually causing the defects. So for example, I'll give you an example. So when you actually see the visualizations of the Cobot torque, so whenever there is a spike or the deviation from the threshold value that we are setting, so this spike can actually be correlated with the inspection results, whether there is any missing component that is being identified at the same time when that spike happens. So this is just an example where the system will overlap and correlate from the inspection data as well as the monitor Cobot health data and helps you identify the root cause. So that is just an example what we are trying to do, and I'll show you what are the results. And finally, whatever the anomalies that we are actually detecting from these correlation data, it triggers automated work order generation within Maximo Manage. We can raise service requests and work orders in a single click. So Edge AI plus asset analytics, what are we trying to do is reduce the false alerts, faster issue resolution, and smarter maintenance decisions. So if you look at the results, this is how the MVI Edge results came out. So we have these memory DIMM inspection results. That is where you can see where the images are being uploaded. The images captured at the inspection station are streamed continuously. We also have AI models that classify pass or fail outcomes within seconds. And these results are sent into Maximo Monitor through MQTT for any kind of visualization and alerts. And this is how the Maximo Monitor view looks like, how we have arrived at the unified view of the Cobot data, trends, and outliers. And if you look at this streams, the Cobot telemetry data in real time, we are trying to detect the outliers, anomalies, and performance drifts automatically that are varying with the Cobot health data. And how are we trying to provide unified dashboards for the critical parameters and asset health trends to ensure better visibility. And finally, on the data correlation side, as I said, we have developed a custom Python function that is actually overlaying the defect data with the asset sensor insights. So any variation or spikes on the Cobot health data is immediately correlated with the inspection data at that point of time or within the window, whether you have any kind of defects or missed defects, and how are we trying to pinpoint to the root causes to prevent any kind of recurring defects. And finally, on the zero-touch alerts and service requests, how are we establishing the closed-loop framework? So this continuous anomaly detection or any kind of threshold breach will trigger real-time alerts, and service requests can be raised instantly within Manage through a single click, or you can even automate that process as well. So this entire process will actually help you form a closed-loop framework, as I already highlighted, how Manage is connected with different applications within the suite, and the applications that we are using here are Manage, Monitor, and MVI Edge. So what is our journey forward? So now that we have executed this pilot case study, what are some of the potential outcomes is almost 50% reduction in the false alerts, because we are moving out from the traditional automated inspection to MVI, and we also have 30% plus faster detection to repair turnaround, and along with 100% adoption of the closed loop inspection to maintenance workflows across industries. So to summarize in a nutshell, what did we do so far? It's all eliminating manual inspection inefficiencies through advanced AI-driven image recognition. How are we trying to integrate those inspections with asset intelligence through correlating quality signals with the real-time asset health insights? And finally, how are we automating maintenance response and resolutions through generating triggers and work orders automatically. So if you look at our journey from pilot to scale, so we have completed the phase 1 where we have done the pilot launch and validation in our Singapore studio on the DIMM inspection use case that we have worked through so far. And we are currently in the phase 2 where we are scaling this use case across IBM facilities, especially on the production environment that we have seen in the IBM Semiconductor packaging line. So we started connecting MVI in that line, and we started collecting the data as well. And finally, what are we trying to aim for our journey forward is to prepare an enterprise adoption blueprint where we can expand these use cases on the predictive quality, maintenance, and inspections across the sites and asset-intensive industries that can adopt with the use cases as well. So if you look at some of the use cases that might be applicable for different industries, specifically on how MVI and APM can work together, within the civil infrastructure, we have some challenges like cracks, corrosions, and stress. Stress levels often go unnoticed, and how MVI is actually used to identify the cracks and surface deteriorations. And when you combine that MVI data with APM, how it will actually correlate with the stress data, any kind of loads and other sensors data from the vibration data from the sensors, and how you can actually identify any kind of early signs of structural stress before any visible degradation, and ideally extend the life of your bridge or the tunnel lifespan. And on the second industry, which is on the rail and transportation, starting with the challenge where we have tracking the defects on the axle and too late, especially leading to costly downtime. On the solution side, we have MVI that detects any kind of misalignment, and we have APM that links the axle load and the vibration data for proactive maintenance. So on the energy and utilities, this is more applicable to the water utilities, where you can connect leaks to the pressure events, where we have hidden leaks in pumps and pipelines that might lead to unaccounted water loss. So MVI can be leveraged there by detecting visual signs of moisture or any kind of leakage, and how APM can correlate these insights with the pressure data or the flow rate data that we are actually collecting to pinpoint any kind of anomalies and trigger early maintenance. And within the oil and gas, how can we predict asset degradation, especially on the early stage surface wear, any kind of leaks or gasket degradation, which often go unnoticed, and how MVI can identify any kind of visible wear or corrosion or seepage, and how APM can correlate these findings with the vibration and pressure data to prevent any kind of unplanned shutdowns and enhance the reliability. So some of the benefit slide, especially on the value realization with Maximo, there's the IDC report where we have multiple parameters that can be enhanced, like overall equipment efficiency, reduce your unplanned downtime, quicker downtime resolution that we have seen, increasing your asset lifespan, along with your accuracy rate and productive technicians. So finally, let's get started. How can you get started specifically? You can start scanning these QR codes if you want to review the solutions that Maximo offers. So you can actually experience a live demo on this Manage plus MVI plus monitor at the MaximoLive IBM booth, which is in the Murphy room, where they're showing how drone to fix use case, especially on the solar farm inspection. So this is exactly a similar use case that we demonstrated in one of the lab. So you can all go visualize how the different Maximo applications can work together and yield value and enhance the throughput. So yeah, you can experience a fully integrated industry demo as well. You can schedule a visit to our innovation studios, which are based out of Singapore or in South Carolina, where you can deep dive into AI-enabled cross-industry use cases. So yeah, that's all I have for today. Thank you for being the wonderful audience. I'll open it for Q&A. Any questions?
Any questions? If not, Surya, in terms of implementation timeline around this kind of Maximo Visual Inspection, can you talk a bit more around how long a typical project of this scale takes?
Yeah, that's a good question. So specifically, if you talk about the timelines, the time that we took for the pilot use case, it's almost around 3 months, I would say, because we did not take much time on the MVI, because the beauty of MVI is you can realize the return on investment within weeks and you can configure the model within hours. The more time we took is on correlating capabilities. So that is where we need to develop a custom Python function. And even within out of the box, we are trying to offer some of the AI models that can correlate these capabilities, especially on the MVI results that you are obtaining from your shop floor and the asset data insights that you are capturing and building some asset health dashboards. So how you can correlate these data, we have taken some time for building a custom Python function, and that's where we almost took around 3 months to execute the pilot case study. And I think it will be even more faster in the current semiconductor packaging line that we are doing it, because we almost have all the connectivity in place, and it shouldn't take more than a month or two.
Thank you.
Yeah.
Thank you very much. Thank you very much for your presentation.
Yeah.
I've just in the practice with us, when it comes for inspection and assessment, usually the obligation for the assessment is much relevant. For example, for the field of oil and gas, much relevant to implement the API codes, for example, or other whatever the compliance should be in there. How Maximo considers this, for example, for the piping API 570, right, or whatever the others equipment for static or rotating equipments, right? So how Maximo consider the compliance with the API codes or Australian inspection codes?
You're talking about API in connecting with the asset?
Yes.
Okay, so as I already said, so Maximo has Edge Data Collector Library, where we already have 1600 plus pre-configured connectors, which are aligned with those particular industry standards. So for example, if you see in semiconductor, we have some standards called SECSDIMM, Semiconductor Equipment Compliance Standard. So within these standards, there are already predefined, pre-built protocols that are within the library. So it is just a click and it is more like a click and play, where you can connect directly to your assets, because it already understands the communication language that your assets will transmit the data. So you have, similarly, you have SCADA, you have PLCs. So if you look at the entire OEM library, starting with Siemens, your ABB, so there is a library within Edge Data Collector that will list out all the OEM's connectors that are already pre-configured. If your assets is falling within that OEM, you can just straight away connect your asset within the pre-configured APIs. Else, if your OEM is not part of that predefined 1600 plus connector library, we can still develop a custom connector for you so that you extract the data as per the compliant standards.
And how about the fitness for service module as well? It is actually Maximo supporting for the asset performance management.
Yeah.
In terms of fitness for service?
Yeah, yeah. So
Just repeat the questions on that one.
yeah.
Sorry.
You can give them.
Sorry. Another point for how the Maximo supports the fitness for service for the equipment.
Can you keep mic nearer?
Oh, yeah. How Maximo supports the fitness for service assessment in here. So if I've got the inspection data and stuff, right, and put it in at the database, so Maximo consider can actually make the assessment as per the compliance code or standard, and make for the fitness for service. How the Maximo supports this? Is it support for this, or is still the reliability engineers or asset integrity engineer has to do his job for this, and then reflect this on the work orders or and so on?
So fitness for surface in the sense, what do you mean? Is it on the
Fitness for surface, for example, let me give you examples. If you've got any equipment like the pump or piping or bridge,
yeah.
The defect for you is actually already inspected and figure out that's the crack.
Yeah, yeah.
Right?
Yeah, yeah.
But the cracks, as everyone knows, has a different range.
Yeah.
Right? So
Yeah.
how can assess the fitness for surface
Yeah.
in case if I would need to make the decision for immediate maintenance repair work, or it can be pushed on or pushed back later on.
Okay.
So that's the fitness for assessment.
Yeah,
Fitness for surface.
Yeah, yeah.
But in the meanwhile, I should be compliance with the standard or the code of the.
Yeah,
Yeah, thank you.
I got your question. So on the MVI side, so whenever you're configuring these AI visual models, especially on the label, train, and deploy, you capture different images, right? Especially on the crack images that you're talking about. Yeah, for example, the crack images that you're talking. So you can define what should be the thickness of the crack, or so it's all customized or pre-configured. So whenever you do this label, train, and deploy, if you set that pre-configured rules and you load the accurate images during the training piece, that is when the results will actually come out more accurately, because MVI uses augmentation technique. So if you define one rule, it will augment and it will generate hundreds of images where your SMEs can see and say what is the acceptance level, what is the level that we can pass on, and what is the defect level. So based on the images that are generated through this augmented process, we also have something called prompt tuning that we launched recently, where it will generate a lot of images, and you can pick and choose which is good, which is bad. So if the training is done accurately, that is where you can actually decide which one to pass and which one to take action and which one to categorize as a defect. I hope I answered your question. Yes, okay, thank you.
Thank you. My question is that, have you, by any chance, benchmarked your visual inspection result against other available off-the-shelf products?
Mm-hmm.
Or if there is any report online available regarding that?
Mm-hmm. Mm-hmm. Yeah, I mean, we actually have other products in the market as well. So the thing where MVI fits in very well within the suite of applications is on the closed loop framework. There are point solutions that are available in the market where you can configure the visual AI models, and it will just capture the images and tell you whether it's a pass or fail. But you can't drive any actions after that defect is detected. That is where this closed loop framework is enabled through Maximo Application Suite, where you can collect MVI data, you can drive the work orders, or the work management, the action that you need to take, especially to close the loop, not just identifying the defect. How do you address the defect? How do you close the defect by executing some work? That is where Maximo offers uniquely. And now with APM coming into picture, you can actually identify the root cause why that defect is happening. If in a manufacturing environment, if a defective product is coming out of a machine, you can correlate if the machine is healthy or not, and why it is producing a defective product. These kind of correlations, tracing back to the root causes. So that is where we offer uniquely within Max.
I totally get the value that there, but on the defect detection side, have you done any benchmarking?
Benchmark in the sense, that is what we are trying to do with this use case, especially in the asset-intensive environments, how Maximo applications can work together. So maybe once we have these production environment implementations done, we can have some benchmarks set. Yeah, please.
I just would like to you to highlight a bit more about rescheduling or reoptimize the maintenance schedules work. So what I mean here, if the data on Maximo for the past failures would be useful if I would use it and reflect it on term of potential of failure, of future failure as well, and then remap it again to reschedule the maintenance work. Mm-hmm. Did you get my point?
No, I didn't get the last part of your question.
All right. I've got the history of the failure.
Yeah.
For whatever the equipment, right?
Yeah.
And I want to use it for reflecting, to addressing on potential of future failure.
Yeah.
And then you buy this direct comparison between the past and the potential.
Yeah.
Right?
Yeah.
The Maximo can go for the reoptimize.
Yeah.
Right, of maintenance, reschedule the work orders again? Or?
Yeah, it can do that, yeah.
Oh.
And in fact, the monitor and health has that option where it can not only it will consider your past historical data of failures, and it will actually give you some of the key parameters like remaining useful life, asset deterioration curves and all that. Okay, already.
Apology here. Perhaps we can take the discussion
Yeah,
separately
I'll
here.
take
Just where we're out of time here. Thank you so much, Surya.
Yep.
Thank you.